Hello everyone, I am the Chem Guy, and today we are looking at this problem in chemistry. Now, the question reads, calcium carbonate of mass 1.0 gram was heated until there was no further change. Now, write an equation for the reaction which took place. 2. Calculate the mass of the residue. 3. Calculate the volume of the gas evolved at STP. Then 4. What would be the volume of the gas measured at 15 degrees Celsius and 760 millimeter of mercury? Given all this value that carbon is 12, oxygen is 16, calcium is 40, and molar volume of a gas at standard temperature and pressure is equals to 22.4 dm3. Now, how do we solve this problem? Now, like I said, this question is basically a stoichiometric question. So the first thing instruction is for us to write an equation for the reaction which took place. Now, I know that calcium carbonate is the same thing as calcium triiosocarbonate 4. So we write the formula of calcium triiosocarbonate 4, that's CaCO3. Now, it's solid because they said it was heated. So it is solid that was heated. Now, it's going to break down into another compound called calcium oxide, also known as burnt lime or burnt lime or quick lime. So calcium oxide, that's CaO. So it's a solid. Now the byproduct will be what? Carbon dioxide or carbon dioxide. All right. So CO2. So this one is a gas. Now, if you check very well now, you check if the equation of the reaction is balanced. Now it's balanced, so it is balanced. Ca, you have one calcium here, you have one calcium here, you have one carbon here, you have one carbon on the other side also as well. Then you also have three oxygen here, one oxygen here plus another two oxygen here. So that's three oxygens in total. So that means the equation of reaction is correct. Now, the next question, we are to calculate the mass of the residue. The mass of the residue. Now, this reaction is a decomposition reaction. So it means that when you are eating it on an evaporating dish, what happens is that the CO2 gas will escape while you'll be left with this. So this is our residue. So the quick lime or burnt lime is our residue. That's calcium oxide. This is our residue. Now, so we want to calculate the mass of the residue that will be left. Now, but before we proceed, let's start with this. You need to also know the molar mass of what you are dealing with. Now, in this case, now we are only working with this and this. That is in question 2. We are working with this and this. So let's rewrite the equation of reaction to give us calcium oxide plus CO2 gas and solid. Now, the next line of action is to identify what you are working with, which is calcium carbonate, because you are giving 1 gram and you are looking for the mass of the residues. So how do we proceed? First thing you are going to do now is to identify the mole, the number of mole in each case. Now this one is 1 mole. Let me put mole here. This one is 1, while this one is also 1. So it is 1:1. Okay? 1 mole, 1 mole. Now, we also need to find the relative molecular mass, or let me say molar mass of calcium carbonate and molar mass of calcium oxide. And you know how to do that already. So if you calculate the molar mass of calcium carbonate, that's 100. That is, you add 40 plus 12 plus 3 times 16. That will give you 100 gram per mole. So for calcium oxide also, for calcium oxide, that's 40 plus what? 40 plus 12, sorry, plus 16. That will give us 56 gram per mole. Now, these are the molar mass of calcium carbonate, the molar mass of calcium oxide. Now, what are you going to do next? So you're going to multiply this mole by this and this mole by this. So it means that mole times molar mass will give you gram. Am I right? So mole times molar mass will give you gram. So by the time you multiply this by this, let me say mass. By the time you multiply this by this, we have 100 gram, and this by this, we have 56 gram. So it means theoretically, if this reaction take place, 100 gram of this will give you 50 gram of this. That's the meaning. Theoretically, 100 gram of calcium carbonate is going to give you 56 gram of calcium oxide. Now, what are we going to do next? Now, in the question, we are given 1 gram of calcium carbonate. 1 gram of calcium carbonate. So we now say, what if you now have 1 gram of calcium carbonate? So how many calcium oxide are we going to get? So easy peasy, lemon squeezy. So we are going to just cross multiply here. So that will be 100 gram times x equals to 1 gram times 56 gram. So that will makes, if you make the x the straight of formula, you're going to have 1 gram times 56 gram over 100 gram. This is going to give us 0.56 gram. All right. So gram of what? Of calcium oxide, which is our residue. Okay, moving on. Let's look at question 3. We are asked to calculate the volume of the gas evolved at STP. The volume of the gas evolved at STP. So to get this, we need to find the number of mole of calcium carbonate. Okay, so how do we find that? We are going to use this formula. N equals to mass over molar mass. So the mass given is what? 1 gram. The molar mass of calcium carbonate is 100 gram per mole. So 1 gram divided by this is going to give us 0.001 one mole. So that's what it's going to give us. Now we'll proceed. Since we have that, so ideally 1 mole of this is supposed to liberate 22.4 dm cube of CO2. So we now write it here. 1 mole is supposed to give us 22.4 dm cube. Okay, now if we're not having this now, so 0.001 mole will liberate dash. So you make x the square of the formula. So you're going to have something like this: 0.001 mole times 22.4 dm cube divided by 1 mole. So mole takes care of mole. So the answer will be what? 0.224 dm cube of CO2. That's the amount of gas. Sorry, that's the volume of gas that will be liberated. Okay, now let's move on to the last question. Last question reads, what would be the volume of gas measured at 15 degrees Celsius and 760 millimeter of mercury? Now, how do we undo that? Now, this question is going to require Charles law. Charles law. Because in Charles law, because the pressure is the same. Standard pressure is still the same to that 760 millimeter of mercury. Now we are also giving 760 millimeter of mercury, but the temperature has changed. So we are going to use that relationship between the volume and temperature to solve this problem. Like I said, we are going to apply Charles' law here. So recall that in Charles' law, V1 over T1 equals to V2 over T2. That's the formula. Now, what is our V1? Our V1 is what we got earlier on, 0.224 dm cube. Now, what's our T1? That's standard temperature. That's 273 Kelvin. Now, V2 is what we are looking for. Now, our T2, we are given 15 degrees Celsius. So we convert that to Kelvin. So that will be 273 plus 15. That will give us 288 Kelvin. So now let's replace these values in these variables here. Okay, so our V1, so we now say 0.224 dm cube over what's our T1, 273 Kelvin equals to V2 that we are looking for over what's our T2? That's 288 Kelvin. Now, so that makes V2 equals to 0.224 dm cube over 273 Kelvin times what? 288 Kelvin. So Kelvin take care of Kelvin. By the time you point this in your calculator, so the answer is going to be 0.236 dm cube. That's how to solve this problem. Mind you, we applied Charles law here.